My name is Bennett Sloan, and I help with the code and prototyping.
My name's Matt McDonald, and I did a portion of the wiring and coding.
My name's Kevin Chow. I helped with the wiring, and I did the video editing.
My name is Manny Bracamontes, and I helped with coding and artifacts.
So the goal of this project was to create a wand housing a bunch of LEDs in a column. It has a sensor to determine what direction the wand is being swung in, and a microcontroller to take in that information and send out a pulse to create a floating image of a word as the wand is being waved back and forth. The wand consists of a row of 7 LEDs, and they're all controlled by an Arduino Uno. When the wand is turned on, it appears to be flickering in a random pattern, but once you get into the back and forth motion, you will start to see the text appear. While the wand is stationary, it will flash in the necessary pattern to display a word as if it was moving, because at that moment it doesn't sense any speed, and so it doesn't display the word.
We have a long breadboard here with 7 red LEDs that are attached to 7 different 220 ohm current limiting resistors, and then these are grounded here. On the reverse side of the board, we have an Arduino Uno clone with the LEDs being fed into the 0 through 6 digital pins. In order to keep fiddling with the placement of the board while we were prototyping, we have the Arduino zip tied onto the board. If we were to make something a little bit more permanent, then we'd look into permanently adhering it to that structure, but that is not the case right now. Alongside with the LEDs, we have the ADXL335 accelerometer that is used as a sensor to determine whether the swing is forward or backward. The X, Y, and Z pins are wired to the analog pins of the Arduino A3, A2, and A1 respectively, with power and ground being fed into A5 and A4. Lastly, to freely swing the wand, we have a 9-volt battery pack as a voltage source for the Arduino.
And here is the demonstration for our project.
So here we've got the program that we've uploaded to the POV board. This is where we input the message to be displayed. We've got a couple of definitions that will be replaced when the program compiles. This line here is basically setting up how many columns we need to display total. So the message is 7 characters long, times 5 for the width of the character, plus 10 to have some spaces in between. This part of the code here is the variables for each of the accelerometer's pins, the X, Y, Z axis input along with power and ground. We initialize all the LEDs as outputs here, give the accelerometer power and ground here. This portion of the code, this loop right here, takes the message and breaks it down into characters, and then with those characters we call addChar function, which is here. It's basically adding all the columns in binary that we need to display. If you actually take this right here and mirror it and then flip it, you can see it's like a physical representation of what that letter is. So these add column functions are all called, so we can look at that down here. It's basically just adding all of those columns together in the message code variable. So once we get the entire message written into binary and added to that message code, then we go down here, see which direction the POV wand is swinging. If it's swinging left or forwards, then we go through this code, which basically writes each column forward. All these modulus statements take that binary value down here and basically sees if that is a 1 or a 0 and displays the corresponding pin or the corresponding LED as either on or off. If we're swinging the other direction, then it will do it in reverse, essentially reading the last column out all the way down until it hits the first column.
As you can see, the current build satisfies the basic requirements one would expect from a POV wand. In an effort to improve upon this design, we also created a similar effect using an Adafruit Feather M0 with a gyroscope and a lithium battery to achieve a smaller form factor and a faster response rate. Another improvement that would be possible thanks to the M0 would be to utilize the surface mount micro USB to load multiple messages and cycle them at will. Of course, one would imagine that with multicolored LEDs and accelerometer time scaling, this type of setup could also create a full spectrum picture that preserves the aspect ratio.